Hi everybody, Dimitris here. In previous videos we built a few props and we run into one problem where some part of the support structure was overlapping with the object, and usually using built-in functionality in reality capture or metashape, dealing with that type of stuff might be quite an issue. To show you what I mean, if we go and look at some of these photographs in loop number 3, I think it should be towards the beginning over here. So as you can see, this structure right there, those kind of two extrusions there, when we rotate it further right there, we start getting some overlap. In this particular case, in this model, it was relatively minor, so in previous video we just ignored that. If we go one frame back, you can see, yes, so we probably got some issues on one of these tentacles, but it's really just a couple of shots here. And when you have something so minor, you can either just ignore it, or I'll show you just in a bit how to do it quickly in Metashape. But if you use reality capture, then you'd have to manually edit one of those masks, because if we switch, I think, yeah, this one, so this one was generated with standard tools in reality capture, and as you can see, we removed our support structure, but it's not reflected here in the mask. So what we would expect to see is like a black area around that extrusion. And as I said, one way is to go in Photoshop and just paint it out. If we were to use Metashape, for instance, let me launch that quickly, and let's add all those images just to show you what that would look like. And we go and find, oh, there you go, so I got lucky there. So we have this one particular shot, and in Metashape you would do something like this. You would just go ahead and sort of paint it over like that, and subtract that from the whole image. So now if we go and visualize our masks, you could see that that particular region would be excluded, and then we could, once we've done that, we can go ahead and go and export masks. When we work with these types of masks in Metashape, and even with reality capture workflow that we'll get to in a bit, we basically have the same file name _mask.png, and in this case you would do all that stuff by hand. You go to your prop pg masks directory. By default it's present, and there's nothing in there, so we can go ahead and export our masks. In that case, we're just going to have one single mask. So as you can see, just that little region is excluded now. So now when we go ahead and build our materials, you could see that this mask would be automatically loaded, and that region would look much better without that occlusion issue. So obviously in this case it's pretty minor, and that's why we ignored it, but let me show you some of the cases where you just cannot do much about it. Like cases like this, where we would scan props and you have to use some clamps or some other stuff that you would have to remove later, and that would appear in all the frames of your loop. Or when we would have something like this, where we absolutely need to scan this shoe from this angle to see the interior, and this is assuming that we don't move the rig around, just the prop. And you can see we have this kind of heel support structure that appears everywhere. So if you go and try to paint it over by hand, that would be quite laborious and that would take a while. Some more examples here. Again, another shoe, and we again have dark black heel and bottom of the shoe, but the support structure now is much brighter. So some people would use Photoshop and like auto masking and stuff like that. Now let me show you kind of a bit more automated way to deal especially with more complex stuff. And so we can close our meta shape for now. We'll get back to that later. But here let's go to our previous reality capture project. So make sure, yes, we have nothing in masks. Let's go ahead and open this one. So this is where we had all our loop models previously, where we basically just removed various parts of the mesh. And in this particular loop number 3, yes, we removed like all the stuff that was on his side, but we also lost that part of the mesh that's supposed to occlude things. So the better way to handle all that stuff, not only when building geometry but also when building materials, is to build that one loop as we did before. So now let's go ahead and exclude loops number 1 and number 2 from our mesh reconstruction. So disable enable mesh and disabled. So we now have that enabled, and what we want to do is we want to build this mesh. Click normal detail. Preview in this case would not be enough, it would be too blobby and it will miss a lot of things. High detail is an overkill for this type of thing, so normal detail is just fine, and it will take maybe a minute or less. There you go. So it took a minute, and as you can see that it's nice that we also have this geometry defined pretty well for these 2 extrusions that cause occlusions when we basically do this type of a loop. Again, I'm repeating myself, but we're using this model just an example. Imagine that we had a lot more frames in this loop, and then we would have a lot more occlusion in this area. Once we have this mesh, all we need to do is to export this mesh and export registration having these this loop images or cameras of this loop selected. So we go to Tools, Export, Mesh and Point Cloud. But now let's go to our prop, Scans, Props, Octopus RC, PG. And in here we have this other folder that's more of a template that's called OCC, that stands for occlusion, and here we have a loop template. So we just go ahead and copy paste it, and it could be called anything at this point. We just call it O3. That would basically, so that we know it's for loop number 3. We go inside, we already have a dummy for our high poly mesh. We export it in PLY format. Yes, replace it. So we want to have normals. Yes, okay. We don't need any textures or anything like that there. And we also need to export registration. So we go, export registration. We already have these RC cameras. We're in the same OCC03 folder. Let's override that. All that is the same as before. Okay. So now if we go to that O3 folder, all we need to do is to open this mesh we will be using MeshLab, and this is our custom version that has some useful tools, but off-the-shelf one would work as well. So, and in here what we want to do, essentially paint vertex colors. And first, when no vertices are selected, we just click on this one to fill everything with white color essentially, and you can see that everything turned white here, and all the parts of the scene that's not part of the object, now we need to select it and turn it black. So this is what I'm going to do now. So we have to go and carefully select everything that we don't really need in this model, in this scene. There you go. Maybe a bit from this side. It doesn't have to be quite accurate there, but we want to make sure that these extrusions are excluded. So that is selected. We click on fill black, and you could use off-the-shelf tools in MeshLab as well, or use any other tool of your choice that has support for vertex painting, because that's all we do here. So now at this point, if we switch to this mode, you can see that our actual model is white and background is going to be white as well, and all the stuff that we don't need, it's still legit true geometry. And as you can see here, you can imagine if this is a loop, then with this mask essentially would be generated automatically, and when it goes behind the object, then there's no mask, so nothing overlaps with an object. So this is a much better way to generate those masks. So at this point, we just go ahead and say export. Yes, we want color, we want normals. Okay, so at this point the model is saved, and all we need to do, again, we're using reality capture, so we need to convert these RC cameras to regular cameras that we use. For that, we just run this script that does the conversion for us. And again, for Metashape, you would export the registration directly into cameras. If you use Zephyr, then there's a special folder with a description of what exactly you click and what exactly you export in here, and then you run the ZFR to cameras XML. So we have those three supported. Anyway, at this point we have our registration, we have our model. Just click render masks, and it will go ahead and render just this one single loop. That's going to be a 1-bit PNG image. There you go. That's finished. If we go to this local masks folder, we could see that pretty much everything is white, and we even see some parts of the model that goes on top of that, and we definitely see those parts where, especially towards the beginning here, where this extrusions, they overlap and they go on top of the object. So in this case, we only pretty much did just vertex painting, and very quick and simple one. So at this point, we want to cut these masks from here and put them into our main masks folder, like so. And at this point, when we go ahead and build our model, we go to solve. We already have our 1K texture build. Let's now, without changing much, just go ahead and create another version of 1K build. We don't have 1K, we have 2K, but that's fine. Let's just copy it and call it 1K masked, and edit the settings file. And here you see the whole difference there between 1K 2K is that we have this local settings files that include the main parameters and then override actual resolution. So here, let's go ahead and set it to 1K. So now we basically would have 1K that we built before without masks, and now this masked one. And if we go and click build script, first it will go through loop number 1, then loop number 2, and once we get to loop number 3, we should see that those masks that we just exported and copied into that pg masks directory, they will be loaded. And you need to make sure that whenever you put something in there, that it has a proper naming convention, and also make sure when you build it, then those files are actually loaded. So we have 3 loops here, so I think at around 66% that's where it will go into loading loop 3 data, and we should see loading of those masks. There you go. So we have 33, 34, 35, and so on. So at least at this point we know that, okay, our masks are loading and everything should be good. So we'll wait until it builds the whole material set, and we'll compare them in Photoshop and see where the difference was. That's great, that's done. Let's also do the transfer. That's done. And let's open, let's say, our albedo texture. It might be easier to actually, yes, use raw ones. Let's open this in Photoshop. And so that we don't lose the track of it, let's call it old. And now let's go back to 1K masked, and also open this, and this is going to be new, and copy that one in there. So we nicely have our 2 versions here. And if now I go ahead and switch between them, I see that in the histogram there is a little bit tiny change, but it's obviously hard to see. So one way to make it better to see, or easier, is to do the difference and then crank up the contrast there. And now we see where all the differences are. And let's have a look at this one. What do we have there? And you can obviously see that in the old one there is definitely some darkness there, and that would correspond to this to that extruded black plastic thing. And in the new one, it definitely, like, all these pixels look more more uniform and more consistent. Obviously this is just an 1K texture, so it's quick to build and quick to see what's going on, do the change. To do the proper thing, we would have to run our 8K build. That would take at least an hour, the way it took last time, and then we compare the results. But this is a general pipeline of how we do things in terms of occlusion and dealing with occlusions. And to go back to our original examples that I started with, like for instance with this clamp over here, now we can open this model, and this is how it was painted, vertex painted for this specific case, for instance. So you would see that the actual thing around the clamp is all black there. The same stuff we would have with the shoe. As you can see, the model quality is pretty low because it was built just for a single loop, and we don't care about the quality of this type of mesh that much. It just, as long as we have enough data to do some vertex painting on it to generate those masks, that's it. That's all we need. And the same, well, here we don't have the mesh, but you can definitely see where it would be very similar to previous shoe. And in other cases, it would be cases like this where you just to put something on a turntable so that it's in a particular position, sometimes you just have to use this type of holders or something and deal with a bit of that occlusion. And this is another example. Like for instance, in this case, the zipper lock was not glued or fixed in any way, so it just hanging like that for some loops. And again, we would want to exclude it so it doesn't create some issues on that part of the model. And when we scan things like that, as you can see, this is a bit of an older build, older scan, where you can definitely see that it's not a good idea to use wide support structures in your scene. Like in here, you can see that there is quite a bit of bounce from this wide box onto the model. And while in this case it was not a problem because there were a lot of other shots with better angles at this area, but in general you want to avoid this type of stuff. So that's why most of the recent stuff that you've seen, we use, if it's a dark scene, you use dark boxes to minimize any of color or light spilling of this sort. So now let's go ahead and create another version of 8K. I'm going to use 16K as a template, and we'll just go to settings here and set it to 8K. But one thing, if you remember, when we build a regular 8K one, it did it in 4 passes. That by default we try to play it safe and split all the work in, regardless of your texture size, of no larger than 4K tiles. And here you, in raw data, you could see that there are like 4 smaller versions of 4K textures there. There you go, you see 4K, and then in the end they all get combined on a single node into final, it could be 8K or 16K textures. And so because of that loading process that has to repeat again and again for each and every tile on the same machine, if you don't have much memory, that's fine. That's the only way to do it, because we have to observe everything at the same time. But in the case when you don't have too many photos or just source footage in general, not too many loops, not too many camera perspectives per loop, then and you have enough memory, then you can get away with building everything faster using larger tiles. And if we go to our parameters for this build, you could see that there are some useful things that are commented out. For instance, here we have a specify custom RAM tile. Larger tiles require more RAM but fewer loading passes. This is what I just talked about. And we have this commented out thing that we can now take and put into our 8K mask settings. So this way essentially we override it. Let's uncomment that and specify 8192. So that would be a whole 8K tile, and we're building an 8K texture. So if we have enough RAM, and we do in this case, then the whole process would be significantly faster. Previously it took almost an hour to build an 8K asset. In this case we'll see that it should take much less time, significantly less. And another thing also, for this specific build, we're going to disable this normal transfer radius thing. That in this case it just would take longer, and we don't really need it in this particular case. So let's put it in here and say that this radius is 0. There you go. So at this point, let's go ahead and click build. And now we just sit and wait. We're going to record the whole process, and you would see that it would take much less time this time around. And while it's doing all the loading, we see overall progress of loading percentage here, and we also see this current RAM that's utilized to store all the data and all the observations. We also see this RAM counter that shows us total utilization in the system. On this particular machine we have 128 gig of RAM, so as long as this value is below 90-95%, we're good, and we keep observing the SPP parameter, samples per pixel. For this type of prop, anything above 50 is a good number, so we'll have good coverage there and good data. And at this point we're approaching the end of the inference phase, 98-99%, and the moment of truth. The whole inference phase took 5 minutes and 40 seconds, and loading was 6 minutes and 50 seconds. At this point it's just finalizing everything, and we'll see the final time. There you go. So basically 13 minutes. And if you remember before, it took almost like an hour or 40 or 50 minutes, something like that. I don't remember at this point. But this way, when you kind of know what you're doing and the types of props that you have, and you know that everything is going to fit in memory on that particular machine, then you can have much faster build times for these types of things. Let's just finish for the post-processing phase to complete, and then we would want to compare that previous 8K build that was not masked and this one that now has this masked build in there. We saw some differences in 1K texture. Let's see how different it is with 8K build. I think it's going to be relatively minor because it was literally just a couple of frames there overlapping with relatively small region of the model. There you go, total time 14 minutes for an 8K final texture build. That's pretty good. So let's go back to 8K raw. Let's open our albedo map from before and go back to what we just built now, raw. Let's see, that's our albedo texture. Let's call it masked and overlay it on top of what we had before. Let's quickly see what the difference is. Where was that one spot we looked at before? There you go. Must be that one. Yep. And let's have a look. Before, after, that's pretty minor. And yes, there was some blackness there, darkness, and that was before, and that's after. Let's have a look at some other region maybe. There were some other differences. Let's say these three. What's the difference there? Before, after, before, after, before, after. So probably most of the stuff you can see here, definitely some highlight from that plastic, some other kind of lines, because that piece of plastic was 3D printed, and you can kind of see this vertical lines there from it, and here it's gone. So you can imagine when you have a much more important larger area that gets occluded by some support structure, then this is a tremendous win there. And sometimes the types of objects that you scan, there's just no way to deal without this occlusion masks. So at this point we pretty much conclude the whole build and processing pipeline. I guess the only other thing I want to mention is how all that naming works. We already had that in our overview video, but if we go to our prop solve and params ini, if you scroll down, you would see here that masks equals, so that's a path to where all those masks are, PG masks. And if there's nothing there, then it won't load anything. And if there's something there that matches a certain pattern, then it will load them. And that pattern is defined in our rig definition file. So if we go ahead and open this rig dev cam, we would see that if our frame label, that's what's exported in the registration file, if it matches that particular pattern, where essentially whatever name is underscore mask.png, and in there it could be really anything, but in this particular case that's the convention that we use. So if we go back to prop pg and we look at our images, let's say it says EOS underscore 01x001, then if you take that name and add to it underscore mask.png and look into masks file, that's what gets loaded there. So sometimes what happens when you use different scripting or different conventions between different builds, that you would put masks in there and they don't get loaded because that pattern doesn't match, and that's why when you build that 1K build, that's the fastest one, you want to make sure that these masks are loaded. That will be it, and I'll see you in another video.